Let's use everything we know and try and look at radical equations. Okay, so let's apply it where we know how to simplify radical expressions. This time we have an equation with a radical expression on each side. So we're trying to solve for x as an actual value, not just simplifying the rational expression. Okay, so the first thing we want to do when there's one radical in the radical equation is we want to move everything that's not a radical, or everything that's not a square root or cube root or whatever, to one side. So this is our square root in this case. We're going to take the negative x and we're going to move it to the other side. So to move it to the other side, we have to add x. And when we add x, we're going to get negative square root x plus 7 equals negative 5 plus x. Okay, and since we have negative root x plus 7, let's divide by negative 1 on both sides. Because see how now this becomes positive x plus 7 square rooted, and this will be, so negative of negative 5 is positive 5, and the negative of positive x is minus x. Okay, perfect. So now remember, whenever we're trying to solve for x, we're just trying to use inverse operations. So in this case, when we wanted to add x on both sides, that got rid of this negative x. So the inverse of minus x is plus x, right? And then we wanted to get rid of this negative, so we divided by negative 1. The inverse operation of multiplying by negative 1 is dividing by negative 1. Okay, so now if we have a square root of x plus 7, remember the opposite, the inverse operation of a square root is a square. So that means we have to square both sides to get rid of that square root. Okay, so if we square the square root of x plus 7, we just get x plus 7. So whatever's on the inside is what we're left with. And then 5 minus x squared. Remember, this isn't just 5 squared minus x squared. This is two brackets multiplying into each other. So it's 5 minus x times 5 minus x. Okay, so once we expand it, right, we FOIL it out. This is going to be 25 minus 10x plus x squared. Okay, now that we have a quadratic, right, we have an x squared term, an x term, and a constant. And the other side, we have an x term and a 7, so a linear term. We want to make everything equal to 0, and then we're going to see if we can factor it. Okay, so since the positive x squared is on the right, let's move everything from the left to the right. So remember, inverse operations, we want to subtract x, subtract 7. So if we do that, we're going to get 0 equals, I'll put the x squared first, x squared. So negative 10x minus x is negative 11x. Okay, and then 25 minus 7, that's going to be plus 18. Okay, so now we want to solve for x. That means we want to factor it. So 0 is going to be equal to x plus or minus something times x plus or minus something. So remember, these numbers that we're adding or subtracting, they have to add to negative 11 and multiply to positive 18. So if we look at our factors of positive 18, the two numbers that multiply to 18 and add to negative 11 are negative 9 and negative 2. Okay, so it's going to be x minus 9, x minus 2. And if these two things are multiplying and they equal 0, that means that either one of these can equal 0, right? Because if x minus 9 is 0, equals 0, right? So if x minus 9 is 0, that means we'll have 0 times whatever this is. And it doesn't even matter what this is, because 0 times anything is just 0. So x minus 9 can equal 0, or x minus 2 can equal 0 for the same reason. Okay, so that means x equals 9, and it can also equal 2. Now, the weird thing with radical equations is these things called extraneous roots. Okay, so whenever we square root or square something in an equation, in this case we squared it on both sides, there's always, or not always, but there's typically an extra solution that comes up. So all we have to do to verify that these are both right is plug it into our original equation. Okay, so let's do the smaller number first. Let's do x equals 2. So I'm going to translate this over. If x was 2, it would be negative 2, right, negative x, minus the square root of 2 plus 7. And that should equal negative 5. Okay, so negative 2 minus, well, the square root of 2 plus 7 is the square root of 9, which is 3. Or not the square root, sorry. Minus 3 equals negative 5. Negative 5 does equal negative 5. So x equals 2 is a valid solution. Okay, so x equals 2 is correct. Now let's do x equals 9, right? That was our other solution. So negative 9, if x was 9, minus the square root of 9 plus 7 equals negative 5. Okay, well that means negative 9 minus the square root of 16, and the square root of 16 is 4, so negative 9 minus 4 equals negative 5. So negative 13 equals negative 5. Okay, so it does not equal negative 5, right? And you might be thinking, well, how the heck does that happen? Like negative 13, that's not even close to negative 5. How did we get that? Well, notice that if this sign here was a plus, if it was negative 9 plus the square root of 16, then that would in fact equal negative 5. But whenever we square something on both sides, the function or the equation kind of assumes that there's a plus or minus solution. So if this kind of term or this symbol between the negative 9 and the 4 could be plus or minus, then 2 and 9 would both be solutions. But that's not the case, right? Because this is always going to be a minus here. So if it's always a minus, there's only one solution where x equals 2. Okay? So x is going to equal 2 is the right answer. Okay, let's do the last one here. So in this case, we have 2 radicals. So I wanted to go through the first one where we had 1 radical. In this equation, we have 2. So how the heck do we do this? Well, kind of the same method. It's just going to take a little bit longer to solve. Okay, we're going to have to probably square something twice. So what I would recommend is if we have 2 radical terms in an equation, I would move one of them over to the other side. Okay, so let's subtract the root 3x minus 2. So we'll have ugly square root. We'll have the square root of 4 plus x equals 2. And then remember, we're subtracting the square root of 3x minus 2. All right. And now we're going to square both sides because the opposite of a square root is a square. So we're going to square the left, square the right. And remember, if we square a square root, we're just left with what's on the inside. That's going to be equal to, well, 2 squared is going to be 4. And then we'll have, here, I'll write it out down here. So we're really just multiplying it by itself. So we have the 4, right? That's the 2 times 2. Now let's do 2 times negative root 3x minus 2. So that's going to be negative 2 root 3x minus 2. Now I have to do this negative root 3x minus 2 times this 2. So we're going to subtract 2 again. And then finally we have 3x minus 2 square rooted times 3x minus 2 square rooted. They're both negative, but that's going to cancel because the negative times a negative is a positive. So we just get plus 3x minus 2, right? Because we're basically squaring the square root. So we get 4, and then combining these terms, minus 4, 3x minus 2, right? And then we get we get 3x plus 2, so we're adding 3x plus 2 minus 2. Okay, got that covered. So we got 4, right? We got minus 4, and then we got plus 3x minus 2. Perfect, okay. So now that we expanded it all out, let's solve now. Okay, so, how can we do this? forgot to put the square root here. Okay, so we have 4 plus x equals 4 minus 4 root 3x minus 2 plus 3x minus 2. So when we FOILed this out, we didn't completely get rid of both square roots. We got rid of this one, but this middle term, right, we didn't need to square it, right? We had 2 times root 3x minus 2 plus 2 root 3x minus 2. Okay, so we still have the square root there. And we're going to do the same method we just did. So if we have a square root on one side of the equation, we want to move everything else to the other side. Okay, so we want to subtract 4. We want to subtract 3x. We want to add 2. Okay, subtract 4, add 3x plus 2. So we're going to get 4 minus 4 is just 0, but then we get plus 2. So we're going to have 2. And then we have x plus 3x, which is going to be plus 4x. That's going to be equal to negative 4 root 3x minus 2. Okay, so what I would do in this case is I would divide everything. Actually, you know what? No, we don't need to. So let's keep it the way it is. Let's square everything. Right? That's exactly what we did in the first one. We have one radical expression in the whole equation, move everything to the other side, then square it. Okay, so we're going to get, let's see, let's do the right side first, with the equal sign over. So since there's no plus or minus going on in here and we're squaring it, all we do is we square the coefficient and we square the square root. So negative 4 times negative 4 is positive 16. And that's going to be multiplying into the square root of 3x minus 2 squared. So times the stuff that's on the inside. Okay, that's going to equal, okay, let's expand 2 plus 4x squared out. So that's the same as 2 plus 4x times 2 plus 4x. Okay, so that's going to be 4 plus 4 plus 8x, and then plus 8x again, and then plus 16x squared. Right? That should be, yeah. So now when we combine these 8x's, we're going to get 4 plus 16x plus 16x squared. 16x squared plus 16x plus 4. Okay, now let's let's divide everything by 4 to simplify, because see how 16, 16, 4, and 16 can all be divided by 4? So if we divide both sides by 4, we'll get 4x squared plus 4x plus 1 equals, well, 16 over 4 is 4, so 4 times 3x minus 2. Okay, now let's expand this 4 into both these numbers. It's going to be 12x minus 8. Oh, whoopsies. My alarm is going off here. There we go. Sorry about that. So now that we have our equation simplified a little bit, now we can actually try and get it equal to 0 on one side and then solve. So we can't really divide by anything on both sides right now because this is a 1. So if this was a 4, we could simplify it even more, but we can't, right? So we're going to have to subtract 12x and add 8 on both sides. Okay, so the 4x squared stays the same. But then we have this 4x minus 12x, which is going to be minus 8x. Right, and then we're going to have 1 plus 8, right? So plus 9. Okay, so right now, this is going to be equal to 0. Let's think if we're going to be able to factor this. I don't believe it's factorable, Okay, so the way we would do this is we'd multiply the 4 into the 9. So that would give us 36. And we would have to think of factors of this that would add up to -8. Okay, so like -6, that won't work. You know, other numbers that multiply out of 36, that's not going to work. So we're going to have to use the quadratic formula for this one. So x is going to be equal to -b plus or minus the square root of b squared minus 4ac over 2a. So -b is going to be 8 plus or minus the square root. B squared is 36, right? -8 squared minus 4 times a, which is 4, times c, which is 9, over 2a, so it's going to be over 8. Okay, I got to get my calculator for this one. So I'm going to go 36 squared, so that's 1,296, and then I'm going to take that, subtract 4 times 4 times 9, it's going to be 1,152. Okay, and the square root of that is 33.94. 8 plus or minus 33.94 over 8. Okay, so let's just simplify this a bit. If we divide both numbers on the top by 8, so we're going to get 1 plus or minus 4.243. So that's going to be, so x is going to equal 5.243 if we add it, and if we subtract it, it's going to be -3.243. Okay, so it's likely that one of these roots are going to be extraneous, and if we wanted to verify that, like, which one was right, we'd plug it into our original equation. But just because these numbers are so ugly, I'm just going to leave it, right? So typically on a test, if there was an extraneous root, you're going to get an answer like this, where it's whole numbers, and we can easily plug it back into the equation and solve, right? But for this one, we had to use the quadratic formula, get an ugly answer. I'm just going to leave it, but it's likely that one of these is wrong, okay? So that's how we can solve radical equations. Hope this was helpful, and I'll see you soon.